Non-viable airborne particles are completely invisible to the naked eye. Yet, if enough of these jagged, microscopic invaders enter a sterile environment, they will shut down a multi-million-dollar production line in seconds. To detect them, QA teams rely on a specific piece of diagnostic hardware, the handheld particle counter. In this breakdown, we are going to decode the exact data these machines output, specifically the 0.5 and 5.0 micron readings, so you can prove your cleanroom compliance to regulatory bodies like the FDA and EMA. If you have your latest particle counter logs nearby, grab them now. We are going to go through a step-by-step diagnostic. Understanding exactly how to interpret these two numbers determines whether your facility passes its next audit or faces a catastrophic shutdown. Step 1 is understanding how this machine captures its data. This cross-section diagram shows the core mechanism inside a particle counter. A vacuum pump continuously draws a controlled sample and air into a central chamber, directly across a high-intensity laser beam. When a physical particle hits that laser, it scatters the light outward toward a photodetector plate. A tiny particle passing through the beam produces a very faint flash. The detector instantly converts that dim light into a short electrical pulse on the output graph. Conversely, when a large particle intersects the laser, it creates a bright flash, generating a much taller electrical pulse on that same graph. The machine's processor translates these pulses continuously. The height of the pulse dictates the specific size of the particle, and the total number of pulses dictates the particle count. This high-speed light scattering process transforms invisible biological threats into measurable diagnostic data. Once your particle counter has collected that raw data, you have to map it against strict regulatory rules. In the pharmaceutical industry, those rules come from ISO 14644-1, 2015, and the updates found in the EU GMP Annex 1 from 2022. Looking at this comparison matrix, we see exactly how these standards apply to your floor plan. The Grade A zone is the heart of your sterile filling operation. The rules here dictate a strict zero-tolerance numeric threshold, both at rest and in operation. As the matrix expands downward, you see Grade B, which acts as the crucial background area supporting Grade A. Then we reach Grades C and D, the secondary monitoring areas, where the particle thresholds progressively loosen. If your air samples fail to meet these specific geographic thresholds, your entire HVAC validation fails. Regulators require explicit proof that these logs show continuous adherence to your zone-specific limits. A simple list of numbers is insufficient for compliance. When you analyze your logs, you'll notice that the regulations mandate tracking two specific particle sizes, 0.5 microns and 5.0 microns. We start with the 0.5 micron reading. These are the most common particles in your cleanroom, making them your primary indicator metric. A sudden spike in 0.5 micron particles is a mechanical warning. It tells your engineering team that the HEPA filtration system is actively degrading. The 5.0 micron particle represents a different threat profile. As you can see, these particles are large, heavy, and asymmetrical. Because of their physical mass, 5.0 micron particles pose a direct biological risk. They act as microscopic taxis for bacteria and fungi. It only takes a single 5.0 micron particle carrying a microbial hitchhiker to concatenate and ruin an entire sterile batch. To properly audit your facility, you must read these two metrics independently. 0.5 warns you about your filter health, while 5.0 warns you about imminent microbial risk. The 2022 Annex 1 update formalized this need for comprehensive oversight through the Contamination Control Strategy, or CCS. This mandate requires a holistic approach to managing the entire sterile environment, rather than viewing tests in isolation. By integrating 0.5 and 5.0 micron data, you provide the evidence needed for a successful CCS, proving to auditors that the facility is under continuous 24/7 control. Bifurcating these two data points allows you to use raw numbers as a predictive shield against both mechanical breakdowns and biological contamination. You now have a complete, actionable framework to read your sensor logs, diagnose specific HVAC risks, and satisfy the strict requirements of Annex 1. Controlling the air is the only way to guarantee patient safety. Once you master the particle count, you secure the entire sterile manufacturing process. If this breakdown helped clarify your audit prep, tap the like button to signal the algorithm. Then, head down to the comments and tell me your biggest challenge during HVAC requalification. Continuous compliance is the bedrock of the pharma industry. Subscribe to the channel for our upcoming deep dives into quality management systems. Until then, keep your metrics under control.